Okay guys, so I'm just going to be testing this DC motor here. It's actually a universal motor. As you can see, it's got the brushes on the outside there, these white things, and inside, I'm not sure if you can see from that angle, possibly yeah, there's a commutator in there. So there you go guys, that's your connection onto the rotor, which is the rotating windings on the inside. And then we've got our stator windings around the outside, but you can't really see them from around here. This is actually a General Electric blow dryer motor. This is actually, so its usual purpose is to dry your hands. Very old one. I'm not sure how old, but it says made in the USA on there. So there you go to all my USA fans. It's 7,500 RPM and it runs at a tenth of a horsepower, which is very low power. 230 volts or 240, I think I can just see on there. 0.85 amps. So yeah, what I plan to use this on is it's going to be used on the rotary spark gap of my Tesla coil. I'm planning to use it on that, but if this experiment doesn't go so well, then I guess not. What I'm actually looking for is control over speed with the DC rectifier there on the little 1 amp variac. That's all it needs. It runs at 0.85 amps, and I've also got a 500 milliamp fuse in the safe block today, so that'll actually tell me if it goes over 500 milliamps. So we shall see. That's 850, that is, so that's 500. So if it goes over that, then we'll know just how much power it's drawing, because I don't have an ammeter set up today, but that's an expendable fuse, so we shall use that. Currently got it set up to the normal control variac here, and we are switched on. We've just got the safe block open up here, so if I close the gap, that's at 0 volts guys, trust me on that as it isn't marked up, but I'll close this. Okay, and I'll take the voltage up on the main variac to simulate normal mains voltage. So there you go, that's 100%. And now I've got this voltmeter here. It's just measuring the volts going into the motor here in DC. It's set to DC guys, so volts DC. So as I crank this up, that should rise up in DC volts. So importantly, I will need to watch to see if the what speed basically the motor will start at and what it goes up to. So this might get loud in a bit as well guys, so just hold your ears if so, or mute your microphones depending on where you are. But okay, so I'm just going to turn this on. This is also another thing to watch out about variacs. I know this one's not because I've already measured it, but some of them actually have a live shaft. So yeah, also other ones have earth shafts and stuff like that. I believe this is an earth shaft, but just as a precautionary, if you're ever running exposed variacs, I know it's quite dangerous to do, but if you know what you're doing and you've got your hands far enough away from the exposed winding, it's okay for test purposes. So what I'm going to do is take the variac up now. See the volts increase, 4, 5, there you go, it's over range, 10, you can hear it humming. So there you go, about 15 volts, that just starts rotating about 15 volts, as you can see. So we'll take them up. 30 volts. What I need is a tachometer to actually measure, but as you can see, that's very good volt control. Nearly 50 volts. Should have hooked the tachometer up for this, but I need another hand then, don't I? 50 volts. That's about that far around. So that's actually a very good speed control up to 50 volts. So we'll take it over. Run this up to full voltage on DC. That's very good control. I just tried this motor on AC on a variac actually. This same variac used about the rectifier, and found that the as I got up to about 20-25 volts, and basically the motor just came on, but there's no real, it came on full speed nearly, but there's no real voltage control over speed. So with a DC setup, easily achievable. Obviously with a bit of load on this, like a actual spark gap running, this is going to run a bit slower than usual for its I'll also draw a few more amps, as you see the safe block still working there. That's 100 volts. Really good control over the RPM of this motor so far. Let's take it up. 55. So I'm not going to go any more than 170. As you can see, that's running quite happily. If I take that down to 150, which is its maximum permitted voltage, see how well you guys can hear me. Also not got my my temperature thermometer today, guys, so you just have to forget about that for now, but I'll measure the temperature with the back of my hand when it's switched off. But yeah, that works pretty well. Take them up a bit more. It's actually bottomed out at 200 volts on the Variac. That's it. That's full load. And it's drawing less than 500 milliamps. I'll take that down. It's actually quite a stiff Variac without a handle on it. I've got to get a handle for this one. It does not have a handle. There we go. Sexy. That has a nice control over speed. A nice range as well. So, alright, that's all the way down. Unplug, safety first. Now, temperature wise, that is cold, guys. That's like, I don't know, it's less than my hand temperature. It's probably near it to room temperature still, so that's on about, what are we on, 15 degrees here? Yeah, 15 degrees, that's probably about there. Brushes. So yeah, that's actually cooling itself quite efficiently, guys. So, I don't know if there's a fan inside there. I don't think there is, but I know it does blow through when it's rotating. So I've seen when I turned these on to begin with, a lot of dust actually came out of them. So they haven't been used for years and years. So you can tell it does actually have an airflow to it. So that's a definite possibility for a rotary spark gap on a Tesla coil then. So I've actually got 2 of these. So if I do mess one up trying to test it, then I can always get another one in there. But if not, I'd probably go for a pulse width modulation. But at the moment, this setup seems pretty good for an RSG rotary spark gap on the Tesla coil. So yeah, unless anyone thinks otherwise, I reckon that'll be the way to go. But anyway, guys, thanks for watching, and I'll see you all again. Bye.